And I'm live. That is pretty cool. Today is 17th of November 2025, Monday, and that is enough of introduction. And yes, we will just be doing Go from Boot.Dev, and that is pretty cool. Boot.Dev and Go. Let's go. Structs in Go. Yeah, structs in Go. Become a member. We cannot. We are not a member. We were on interfaces, and then we will have error handling, then loops, pointers. We have pointers, but someone said that Go does not have genuine pointers but weak pointers. Okay, so pointers, and then package management, channels, mutexes, that would be cool, generics, enums in Rust are pretty amazing. And then there would be some projects in Go, I suppose. Learn HTTP clients in Go. That is just 83 chapters, and KDX in Go. We can actually, by the way, like take, go through this whole Boot.Dev course. That would be cool. That would actually be cool. Building a booklet in Go. Lane Wagner, build a also available in TypeScript. Build a REPL Pokédex on the command line in Go. On the command line in Go, that would be cool. 24 hours of context. 12 addicting lessons. So if you do take these lessons, you'll just keep taking them again and again. I suppose addicting. That's cool. REPL as in like read, evaluate, print, loop. Okay, cool. Let's go to Go. Yeah, go to Go interfaces. And the chapter that we were at, interfaces quiz. There's a quiz. Interfaces. We did mess up, or like we did try out interfaces. Share where is the thing? May not go. Yep. Here we had a interface, and the name of the interface is machine, and interfaces have functions, methods is the better word. Interfaces have methods which are associated with them, and when we create a structure and give those same exact methods to the structure, then we say that this type, in this case, which is process, which is steam machine, this type is implementing the interface, and the interface in this case is the machine interface. And here we have two types which implement this interface, which are steam machine is one type, and quantum comp is another type, and they are both implementing the machine interface. And also this thing, quantum computer, has a extra method called printer, which is not defined in the machine interface, but is still, we can say that quantum computer is implementing the machine interface. So for a type or a structure to implement an interface, that must have at least all the methods which are a part of the interface which we are trying to implement. And after that, we can have any number of extra methods. Extra methods don't really matter. Hello, recursion. Let's go. Uh, weakest among the weakest among the weaks. Okay, shit. That is a cool username. When did you start learning Golang? I guess this is the fourth stream. And recursion. I don't understand recursion. Please, bro. Recursion. Recursion is a function calling itself. Let's write some. We can actually do something here. We can here implement a structure. Yep. We can implement a structure type fact struct, and this thing will have a value x, which is going to be an integer, and that is it. And now we will implement a few methods on this. One method will give us the factorial of x. by recursively calling the method which returns the factorial of x. So that would be cool. Shit. Yes, that would be cool. Or we can simply write a function that return that takes in x, which is an integer, and returns an integer. And if x, we don't have this, if x equals 1, then return 1. Else, if x is not equal to 1, then return x minus 1 into x. That is just the base definition of recursion. Do you study CS in university? No one studies CS in university. And hello, good afternoon. No, no one studies CS, at least in the place that I live in. Yeah, that is just basic recursion. And what I want to do is, can we write a recursive method on this fact structure that will give us the factorial of x? I think we might be able to. Func on f fact, and the name is fact get factorial get, and this takes in nothing and returns an integer. Okay, so if f dot x equal 1, return 1. Else we cannot call fact dot get because it will give us the factorial of x. So return f dot x multiply by, we will write a new structure. Can we write a in place structure? I think we might be able to. Fact, yes, fact structure, and give this the value for x, give it value f dot x minus 1. And on this call fact get, and that is crazy recursion. Okay, that is actually crazy recursion. That is crazy recursion. Let's write a thing here. My structure equals fact where x equals, let's say, 10, and then println my struct dot fact get, and that is cool. This method will give the factorial of x. Let's also write another method which it's on f fact and fact increase, which doesn't take in anything and doesn't even return anything. It will just do f dot x plus plus. So after this, we'll call my str dot fact increase x by 1, and it will become 11. But this is very inefficient because if fx is not equal to 1, we are creating a new structure and then calling the fact that get function, which is internally also probably creating another structure and calling the same thing. That is not very good. My stir dot fact get. Let's see, go run uh go run dot. That is wrong. The value was didn't increase. Yes, because this is passed in by value, and now this is passed in by reference, and now the value should and would increase. Would and should increase, yes, and it did increase. So this is the factorial for 10, and yeah, so that is cool. Now, you got what I mean. Do you go to uni for a CS in bachelor's or a bachelor in CS? Yes. Um, yes, unfortunately. Degrees, like, yeah, you will have to get a degree for int I for shit. This is not C++. Okay, int for I equals 1, I is smaller than 10, and I plus plus will run a loop where println my str dot back get, and then my str dot that increase. Let's see, and go run dot. Yo, factorial of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 10. Yeah, 10. So that is cool. That is cool. We are getting factorials, and that is recursion 101. And now back to interfaces. I guess, yeah, we only did the mm, first thing here, and yeah, we did this. Now moving on to this in the guest mode. Okay, interfaces are implemented implicitly. Implicitly. Yes, interfaces are implemented implicitly. Yes, that is a true statement, a tautology. Because we are not specifically saying that we have this structure which is going to implement this interface. We are implementing the interface implicitly, not explicitly. That is true. A type never declares that it implements a given instance. Yes, a given interface. If an interface exists and a type has the proper methods defined, then the type automatically fulfills that interface. And that is the only requirement for a type to implement an interface. That is the type which is implementing an interface. That type should have all of the methods which have been listed in the interface. But after that, the structure, the type can have any other things, any additional things, they don't matter. But yeah, the minimal required things should be there. Um, a quick way of checking whether a struct implements an interface is to declare a function that takes an interface as an argument. If the function takes the structure as an argument, then the structure implements the interface. That is pretty true. At Textio, we have full-time employees and contract employees. We have been tasked with making a more general employee interface so that dealing with different employee types is simpler. Okay, this is kind of very less efficient because we cannot actually do this. And yeah, because for me, I have had some experience with programming. So doing all of these questions is not very cool. And I what so realistically speaking, going through all of these remaining things in the interface section, I think is not very necessary because I'm not actually using interfaces right now, and having knowledge about something which I might not be needing in the future is not very cool. Instead, I can go to errors. Do I need errors? Yes, a basic understanding of different concepts in a language is cool, and whenever a more thorough understanding is required, we can just go and look it up. Like, yeah, we can just go, and no pun intended, which is, I think, a better model for learning. But with a language like C++, I would suggest, which the thing that I did with C++ was going through the C++ book and that was very difficult. Go programs express errors with error values. Okay, error is an interface. Shit, okay, makes sense. An error is any type that implements the simple built-in error interface. Okay, okay, an error is any type that implements this interface, which has a method called error, which returns a string. That is cool. When something can go wrong in a function, that function should return an error, and an error is any type that implements the error interface, which is this. Cool. As its last return value. Any code that calls a function that can return an error should handle errors by testing whether the error is nil. Yeah, because this returns a string and the string could be nil. ATOI, like ASCII to integer. Let's look at how stir_conv.atoi function uses this pattern. The function signature of ATOI is this. This returns two things, an integer and an error. This is like Rust. This is like Rust. So, Shed, yes, this is like Rust. We are not saying that the function might return an error or might return the correct value, and you are not putting your code in a try-catch loop. Your function will return an error and will return a value, but if the error is nil, then the value is valid, but if the error is there, then the value is not valid. So that is cool, and you are handling error. You like must handle the error to make the program compile. So that is cool. This means ATOI takes a string argument and returns two values, an integer and an error. If the string can be successfully converted to an integer, ATOI returns an integer and a nil error. If the conversion fails, it returns 0 and a non-nil error. Makes sense. Here is how you would safely use ATOI. String convert this string into a number and take the I integer and the error. If error is not equal to nil, then format print is not equal to nil, then there was an error and we are printing the error. Cool. This isn't a valid integer, so there would be an error. Yeah, if there is no error, then yeah, then we will handle I however we want to handle I. That is cool. That is cool. That is cool. And we can move on to the next one. And formatting strings. And also, after reading this a little bit more, I will do some code forces questions in Go. That would be nice. A convenient way to format strings in Go is by using the standard libraries FMT sprint format. So this function takes in the same arguments that you would give to printf in C or C++, and this function does not print the string to the console, but instead it returns the string as the output. So that's cool. It is a string interpolation function similar to Python's f strings. This is like by default, whatever the value is, it will try to print the default representation of a value, this thing. Or you can be more specific and provide %d, %f, or %s for integers, floats, and for strings. Or you could use this generic type. This substring uses the type's default formatting, which is often what you want. Default values: Kim, Hans Kim 22, and format as print v name and age. Kim is 22 years old. The equivalent Python code would be this. Yeah, with a F at the start and these things in the middle, or in Rust we also use the curly braces. Rounding floats, we can round the floats. This would round the float, or we can specify round down to two values. Assignment, we'll be writing code in code forces. Okay, we have defined a struct user error, which has a name string, and we are implementing the error method onto this structure, and we are saying this error method does not take in anything but returns a string and returns what? This thing name has a problem with your account. This can be used as an error. This function takes in a message and the username and returns an error. If cannot be sent to user name, this return user error this type where the name is name, and this thing, this structure is an error structure because it implements the error interface. So that is pretty cool. That is pretty cool. And what have we seen in errors? For a structure or a type to implement an error means it has to implement the error interface, which is right this one. It should have a method with name error e capital and doesn't take in any arguments but returns a string. That is the only requirement for a error or a structure to be an error type, and that is cool. And for a function which can return an error, that function will always return an error. You just have to check. Wait, I think it was in the first one. Yeah, you just have to check that was the error nil or not nil. Error is always written. You just have to check if it is nil or not nil. Yo, hello, I am in my third year, and yes, error interface, that is something. And then now the quiz, error quiz, and shit, there is a video. That is cool. What is the underlying type of an error? Underlying type of an error would be a structure. We cannot answer the quiz because we do not have the premium. Okay, but the answer would be structure. That is cool. Go programs express errors with error values. Error values are any type that implements the simple built-in error interfaces. Yes, keep in mind that the way Go handles error is fairly unique. Most languages treat error as something special and different. For example, Python, yeah, raises exceptions, and you have to write your code in a try catch block, and JavaScript also does the same thing. So you have to keep in mind to write exceptional code, and code which can return exceptions or errors inside a try catch statement, and if you forget that, then there might be an error. So that is not very cool, but in Go it will return an error. Go, an error is just another value that we handle like any other value however we want. There aren't any special keywords for dealing with them. That is pretty cool. And now the video. Yep.
Go does not handle errors the same way that languages like Java, JavaScript, and Python do. JavaScript, for example, uses a try-catch paradigm. Let's pretend we have a function called getUser. We probably need to wrap the call to getUser in a try block because it's a function that might throw an error. For example, maybe the user doesn't exist. And in that case, the catch block runs instead. Now, Go does not have try-catch blocks. Instead, it just returns errors like it does any other value. If everything goes well, the error is nil. We continue to the next lines of code just like normal. In this example, if something does go wrong, the error variable, usually called err, will not be nil. So we just handle the error, say by printing it and returning early. But if everything does go well, then the error will be nil. And it means we can just continue to the next lines of code. For example, maybe we want to get a user's profile picture based on their ID. So we call that function that also can return an error. So again, we handle the error either by bailing or just continuing. There are no exceptions or throwing, we just have a simple conditional check, an if statement. So functions that can fail in Go return an error value as their last return value, and We, as the caller of the function, are just expected to check it. Now, there are two main reasons I prefer Go's method of error handling over try catch. The first is it makes for a really straightforward control flow. There's no magic that jumps us out of a block that we're in, like the throw keyword does. The code just executes line by line, even when things go wrong. And second, it's explicit. You can see that a function might return an error just by looking at its return type. In JavaScript, the return type does not tell you whether a function might throw an error or not. You just kind of have to know. In Go, you can't ignore potential errors unless you really go out of your way to do so.
Yes, and that is cool. Go's error is actually cool. I thought that was audible, and yeah, it might have been audible. So yeah, that is a pretty cool way for handling errors. You know explicitly what you are doing, and that is cool. The same video, and can you type an error and also fulfill another interface? Yes. Yes. I think yes, that should be possible. Let's see. Let's see. Uh, let's see. Yeah. Wait. And then dot lua, nope. Options dot lua. Split tabs. Expand tab is true, but it is not true at the same time. Go dot mod, and okay, let's say we have a factorial interface that says that there should be a function called fact get, which doesn't take in anything but returns an integer. So yeah, this fact structure is an implementation of this factorial interface. So that is cool. And let's also make this thing a error, so that func f fact will have a method called error, which doesn't take in anything but returns a string. And yeah, this will just return a string. Return cannot find the factorial. And yeah, cannot find the factorial, and that would be when if f dot x dot x is, let's say, greater than 15, then return f dot error. 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 Return f. This thing returns an integer or an error, and in this case return 1, and f here return -1 and f, and fact. This is the first thing, and the second thing which we have to return is f. Shit, that is true. That is true. This thing is true because this fact get fact function is returning two things, and we cannot multiply two things by a single thing. That makes sense. So I comma air equals create new fact where x is value is f dot x minus 1, and call the fact get function on this I undefined air. Yes, because walrus operator. And yeah, then just return f dot x into I, comma F. We don't really need the value of this error, so that is cool, and this is cool. This is cool. So yeah, at the same time, a structure can be an error and also fulfill any other interface at the same time. So that is kind of cool. New error package. The Go standard library provides an errors package that makes it easy to deal with errors. And errors, Kelly draw. There is an interface. There is an interface of error which doesn't take in anything but returns a string. There's this interface. Yeah, error interface. And every structure that has a method error which returns a string is an error. So that is very cool. That is cool. That does make sense. Everything like that is an error. So that is cool. That is cool. That is cool. Every structure that has a method named error, which doesn't take in anything but returns a string, is a error interface. And we can have a bunch of error interfaces. Let's have some error interfaces. Let's say type err1 error 1. This is a struct which has nothing, literally has nothing else. Yeah, literally this thing doesn't have anything else. This thing will only have a function defined for this e1 error 1. The name of the function is error, which returns a string, and this is uh, return error number 1 for you. Yeah, so E1 is an error. Error 1 is a error. And type error 2 struct, it doesn't have anything internally. It only has a method defined for itself. E error 2, the name of the method is error, which returns a string, and this says error number 2 for you. And let's write one more error where this 2 will be substituted with 3. And let's write a function that is named return error, and this takes in an integer x and returns I and an error. I returns I, which is an integer, and also an error, which is an error. Okay, and if x is equals 1, then return -1 comma error 1. Error 1 type is not an expression. Yeah, there was problem because we have to create a structure of type error 1 and then return it. And then if, okay, we will not be using these brackets. And if x equals 2, then return -1 error 2. That is cool. And if x equals 3, return -3 and error 3. Else In any case else, we will say we will return an empty error. An empty error. How do we check for an empty error? We check by checking if it is null. So what should it have internally? Return an error right here. If error is not equal to nil, okay, we can just return nil in any other case. Let's say else we'll just return x comma nil. That works. That is good. That is cool. And here we will go through a loop for I equals 1, I smaller than equal to, let's say 4, 5, and I plus plus. We have a loop here, and the lack of brackets, the lack of norm parentheses is kind of crazy. We will call the return error function with I, and yeah, we'll catch the return values. This will return x and some error, and if error equals nil, or if error is not equal to nil. If error is not equal to nil, then there is an error, and we will say print ln error dot error, error dot error. Else, if there was no error, then we will say print ln no error, and x was no error, and x was returned. So that is cool. Let's see. Shit. We also have to uh, say if there is an error, then don't execute the following code and continue. Go run this thing, and error number 1 for you, error number 2 for you, error number 3 for you, and no error 4 was returned, no error 5 was returned. So that is kind of cool error handling. Yeah, and then the error package. Read the docs for new errors dot new function, but here is a simple example. Okay, we can get an error by calling this. I think we can write our own implementation for this function. Yeah, we can write our own implementation for this function. Errors. Yeah, we can write our own implementation for this function. Let's do this. We can write our own implementation for this function. We have a function whose name is errors, and this function takes in s, which is this function does not take in anything. This is not even a function. This is a structure which has a method new. So errors is a structure. Errors, and this is a structure which is empty. Now we will define a method on each errors, and the name of the method would be new. It takes in a string s and returns an error, interface, and this is the function body. And what does this do? This will return a structure that implements the error interface and returns the string s when we call the dot error method on the returned object by this function. Okay. New. I think, can we define type Air struct. Yeah, we can define a structure inside here, so that is cool. Func, this thing will have e r e r r, and this will have a method called error. This will have a method called error, which doesn't take in anything but returns a string. And yeah, what is the string that this thing returns? This returns s. Expected this not found. Func on error. This returns a string. Why would you expect something here? Func on return s. This thing. Okay. They think we are calling a function called error, even though we do not have a function called error. We have this function here, which returns an error, but we are not calling an error thing. Why, if we say let's define this error interface outside, type err, which is a empty structure, and function for this e error is, and returns a string, return war. Shit, undefined s makes sense. So we will have to define this thing internally here, but I don't know why we are getting this problem. Okay, we can define this outside. We can define this outside, and here this thing will have s as a string, and we will return e dot s. And here we will create return air where s equals s. So that is cool. And if here we say air equals errors dot new and say this is an error that checks out, but to call this we have to make this a structure, and this is fine. This is fine. Println error dot error. Here we have to call this, make a structure out of this thing, and then do this. So this is a structure which already exists, which already exists. Error creator. Uh, error creator, and here we'll say error of type error creator. Does that work? Expected declaration found errors. Expected declaration found errors. But if we were to do this here, we don't get an error. Now this checks out. This is like, yeah, this whole statement is similar to this. So yeah, in essence, we have implemented our own error creator function. So that is cool. Like actually, okay. And moving on to the next thing, panic is a Rust thing. Panic and also kernel panic is something. As we have seen, the proper way to handle errors in Go is to make use of the error interface. Makes sense, that is a true statement, tautology. Pass errors up to the call stack, treating them as normal values. Pass errors onto the call stack, treating them as normal values makes sense, and we can, whenever a function returns an error, we can check if the error is nil or not. If a function is capable of returning an error, then it will return an error. So this is like not optional that the function might or might not return an error. If a function is capable, it will return an error, just like a normal value. So that is cool. Ross Ulbricht. A user error get user ID and goated error FMT. Error F is goated, it wraps an error with additional context. That is cool. That is cool. Because for a type or a structure to implement an interface, we just need the methods to be defined for that structure which are a part of the interface which it is implementing, right? The error method should be there, but additionally, after, if an interface has the error method, after having the error method, the interface can have all other methods if it wants some other methods, if it wants. So that's cool. Panic, however, there is another way to deal with errors in Go, the panic function. When a function calls panic, the program crashes and prints a stack trace. As a general use, do not use panic. Do not panic, okay? The panic function yeets control out of current function and up the call stack until it reaches a function that differs or recover. Differ, we did saw differ yesterday. Differ, we provide a function to differ, and when we call a function, if there is a differ statement in that function, so whenever that function returns, whatever function we provided to the differ statement will run whenever the function returns, no matter where the function is returning. So that is cool. If no function calls recover, then the Go routine, often the entire program crashes. Indirect user, and here we are panicking in this indirect user function, and yep, a differ function. In this function, if r equal recover, if r is something, okay, yes, here we are initializing r, and then we are checking if r is not equal to nil, that is we did panic or something, then recovered from panic with r. Otherwise we won't just, yeah, we won't recover from panicking. Sometimes new Go developers look at panic, recover, and think this like try catch. I like this. Don't be like them. Okay, don't be like them. This is different. This is much better, because in a try catch, you, in your catch statement, you are only going to catch the things which you have put in the try statement. But here, when using differ, no matter where the error comes in the whole function, you will be able to handle it. And yeah, so that's cool. That is actually kind of cool. So panic and recover should be used instead of errors. Panic and recovers, no, no, panic and recovers should not be used. They are there if there is some catastrophic mistake in the code, but you should not use panic and recover. You would be much better off if you are going with errors. Why? Because errors are handleable, and panic and recover will crash the program if you are not careful. When your fingers are tired, you don't care anymore. Nope. When you want to make your code more readable, nope. When you want more control over the code, error handling, nope. Basically never. Yeah, basically never. That is the correct option, which we cannot even check. We just have to hope that is the correct option. Okay. And we are on panic mode, which is again a question. If you want your program to cleanly exit in an unrecoverable way, which is a good alternative to panic in an unrecoverable way, which is a good alternative to panic. If you want to exit a function, I don't know, fatal, hmm, how to cleanly exit a program. I guess one of these functions would be used. Kill maybe. Log.fatal, that does not look like a clean way. How to exit. We can actually check. We can actually check here. Um, is kill something? Kill is not defined, or maybe kill is a part of something else. Println, why would you use println to exit? Boost.exit would not be a thing, I guess. And log.fatal does not even make sense here. I guess kill is the thing. Exit in program. How to stop a Go program internally. os.exit. So none of them. Boost is the most similar thing. os.exit. Yeah. No arguments given. What is the argument that are required? An integer. Yeah, exit code makes sense. 0. Yeah, so that does work. We can use exit to exit a program. That is cool. And user input index, your users can set their profile status to communicate their current activity that to those that choose to read it. However, there are some restrictions on what these statuses can contain. Your task is to implement a function that validates a user's update. The okay, the status update cannot be empty and must not exceed 140 characters, which we cannot do here. So let's do some code forces in Go. That is cool. Yo, anime girl. Uh, problem set. Let's do, I guess, some 1400 rated problems in Go. New kingdom. Something trapped in the witch's labyrinth. And yeah, I hope we don't get. Let's solve a simpler problem because, yeah, let's solve advent of code. Advent of code. Yes, let's go with advent of code. Yeah, let's actually go with advent of code. Okay, I have solved 2016, two questions in 2016. Let's go. Yeah, we'll be solving this year's 2016's advent of code for practice purposes. AFC advent of code, get a status, and did this get no feature log, and the graph for this thing I think is like actually pretty crazy. One line. Let's see the last 15 commits. Okay, it is not crazy at all because all shit, that is crazy. Let's see, not 15, but the whole history. So that is a lot of here and there stuff. Look at this. That is a lot of branching. And 2016, the head is at 2016 currently. And let's get push region 2016, and everything is up to date. So that is cool. Let's do day 2. Yeah, let's see day 2. And this is the question. Easter Bunny headquarters. Let's do this with some water on the way. advent of code is pretty cool. Okay, you arrived at Easter Bunny headquarters under cover of darkness. However, you left in such a rush that you forgot to use the bathroom. Fancy office buildings like this one usually have keypad locks on their bathrooms. Okay, so you search the front desk for the code. In order to improve security, the document you find says bathroom codes will no longer be written down. Instead, please memorize and follow the procedure below to access the bathrooms. The document goes on to explain that each button to be pressed can be found by starting on the previous button and moving to adjacent buttons on the keypad. U moves up, D moves down, L moves left, R moves right. Each line of the instruction corresponds to one button starting at the previous button. So for the first line, the 5 button. Press whatever button you are on at the end of each line. If a move doesn't lead to a button, ignore it. What does that mean? You cannot hold it much longer, so you decide to figure out the code as you walk to the bathroom. You picture a keypad like this. Suppose your instructions are this. So where do you start at 5. Okay, we start at 5, the button 5. Or for the first line, you start by 5, move up, go to 2. 5, we move up and we go to, because of up makes sense, and then we go left to 1 and left you cannot, so you stay on 1. Okay, so the first button is 1. Okay, makes sense. Okay, so the first button is 1, then RR, from 5 we go to R right, 6, then we go to right, we cannot go to right, so we stay at 6, then we go down down down, so 9, so the next number is 9, next number is 9, then left, up, right, down, left. 4 is the next number. No, 8 is the next number. Okay, we have to continue from the last button. Okay, it makes sense. We start from 5, then we went to 1, and from 1 we went right once, then right once, and then down 3 times. D D D. So down, down, and down. 9. So 9 was the second answer, and then we started from 9 and we went left, up, right, down, left. We went to 8. Okay, and from 8 was the third digit, and then 1985. Shit, what happened in 1985? I guess uh in 1985 Iran and Iraq were fighting. Okay, then from 8 we start from 8 and we go up 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 to 2, and then from that we go to down 5. So the last thing is 5. Okay, so what is the bathroom code for us? Where this is the input, and Google said that this is Icelandic. Good. That is how Icelandic language sounds like, looks like. So let's do this. mkdir or and.txt text. That kill is not the thing. Okay, we do have the input, so that is kind of cool. And yes, how to read the file and all the other logic. Let's see. We'll have to see how do we read a file. And yes, this is the question. If you want to follow along, you can follow along in Advent of Code. Advent of Code is actually pretty cool. Sync everything working and everything is synced up. For shit, why do we have day 0 question? Which actually has some stuff in there. So that is kind of crazy. Part1.go, how are we reading things? Let's see. File path dot join path. So what is returned by this thing? This thing returns a normal string. Shit. So I guess even if we remove this, we have a valid working thing. And instead of this here, this should also work. I guess this should also work. This is part1 dot go. So back day 00 go and output out part1 dot go should go build out part1 dot go. Command line arguments file path imported and not used. Okay, my bad. We are not using file path, and that is not just giving us an error, a warning, that is not letting us compile the program. That does work. That does work. So that is cool. We can use this to get the data and read things, and data would be a byte, array of bytes. So that is cool. And since we only have ASCII characters, so this is going to be nice. This is going to be nice. We'll take this. Yeah, let's do this. Day 2. Part1 dot go and yeah, func main, and in here we will have data and error equals os dot, and next we have to say package main data dot error equals dot read file, and the file is dot slash text dot txt. os is not imported. We can import with normal brackets fmt, import fmt and os. Missing import path. How do we import here? Okay. Uh, we have to ramp this thing. Okay. Okay. That is cool. Data and error. So okay, if error is not equal to nil, or this is a very small program, we don't have to care about errors. So we have the data, which is a array of bytes, which we will split, and what do we say? We'll say lines, which is string thing. I think that is how we can say this. And then string dot split, and what do we want to split? Split at new line data. Data is not a string, data is a other thing. So how do we handle that? Trim space, okay. Convert data into a string. Then trim, that is from the ends. Trim space, okay. Remove all the spaces, and then after that split on commas. That is what we are doing here. So here we will have lines equals strings dot split. Split, first thing has to be a string, and we will convert data into a string, and we want to split at new line. That is good. We do have the lines now. Yeah, we do have the lines now. We'll say in C, or this is not C plus plus. C equals 5. 5. 5. 5 integer or a character, a byte. Yes. And then we will also have a response which is a empty string. And then for I x in can we use the syntax for x in lines? Okay, how do we use for in syntax? For this in range. Okay, that makes sense. Okay, for this equals for x in range lines. Okay, we are just getting used to the Go syntax. At the end, we will fmp dot print response. Now, here we are going line by line, and in this line, we will go through all the characters. So for let's call this current. Now for C in range x, x is a string, so C is the current character in the string that we are in, right? Yo, hello. You can just create a separate function like check or something which would take an error and would panic with that error message. That's how I usually handle it. It removes repetition and cluster. That is nice. You know, like this is just a competitive programming, kind of competitive programming question. Since we are learning Go, we should do that. This thing takes in E, which is error, and you are suggesting that we should just panic. That is also something. Okay, this won't. This will return a boolean. Let's say, yeah, this will return a boolean, and if E uh, equals nil, then return true. Otherwise, panic. Total chaos. What is the problem with this? Invalid operation, not enough arguments. Okay, what does it want for argument? Anything would work. Error check. And here we can see check error. That is nice. And read line and current. Okay. So for now we are going character by character and we need a switch statement. Switch on C, and the cool thing about Go is we don't need break inside this. And this will be L. And if L, we can just move towards left. If can we, yeah, if the CURR is not 1, 4, and 7, then just subtract 1 from CURR. So how do we check without using multiple and statements? Can we give a list and then check? That would be cool. No need to return anything, just to panic E share. Panic with the error. That makes sense. That makes sense. Panic with the error which was given. What else? What would be the use of this function? That makes sense. Panic with the error. No need. We expect the program to crash. That does make sense. Bro has been at this for some time, I suppose. If E is not equal to nil, if there is an error, then panic. And if there is no error, then we'll just, yeah, go forward. And ChatGPT or maybe some human help. How to check if a value is, because there is the trivial way that we can check here. Uh, Cur is not equal to 1 and cur is not equal to 4 and cur is not equal to 7. Then cur minus 1 or minus equals 1. I think we can do minus on a character in Go. We can do that in C, but also in Go. That is cool. And is there a benefit to make this a character? I don't think so. And at the end, whatever the value is of cur, we will say rest plus equals char cur. Char is not a thing. Byte is a thing. Byte is not even a thing. RUNE, uh, UNE is a thing, but that is also not a thing. Mismatch types how to append a character to Go string. How do we do that? This and this is what we want to append, and new string equals original string. Okay, there is no plus equals to, so okay. Rest equals rest plus rune cur. Shit. Mismatch types. Okay, I guess with this string syntax, this uh, this also works. String syntax. String conversion from int to string yields a string of one rune, not a string of digits. String of okay strings dot there might be a function for this. And integer to string Golang stir convert ITOE that is one thing. And yeah, we could use this, but I think that would be more heavy than this. And stir convert format integer, that might also be heavy. That might also be heavy. So just do if error is not equal to nil, panic. Yo, you can press equal to in normal mode for auto indentation based on your setting. Yes. Make it a list of rune and use append function. Append, make it a list of runes and use append function. Okay, let's see do some testing. Language is go and test dot go and package main func main. If I have an integer x equal to 5 and then I do print line char rune x, will I see 5 or will I see, yeah, will I see 5 or the ASCII character which is represented by the integer 5? Let's see. Go build test dot go build out test dot go 5. Shit. This might not be, because this might not be we didn't see 5, we saw 5, maybe not, because x is getting converted into a rune which has 5 internally. I think this might also have been because print ln, when we give it integer type because rune is internally an integer, so it represents that integer. Yeah, it will print the integer. Shit, this is like not even changing the type of 5. Because rune is just an alias. So we are technically just printing a integer. We are just printing a integer. If we do string, then go build a slash out, and that is what I expected. Okay, yes. When we do actually convert this into a character type using the string function, we don't see the number 5. We are seeing the ASCII value which is represented by the integer 5. So that is subtle. Uh, I don't know what you're trying to do. Okay, I'm just trying to see what actually happens here. I think basically just integer type. So Go would just, yeah, 5 is printed because as an integer. And this was 5. We saw 5 on the screen because printf or println converted that integer 5 into a character 5. Takes so much time to show my comments. Shit. I guess some biases. That is crazy. Import OS and okay, why are we in this function here? Why even are we in this thing here? Okay, and let's go back to AOC. Day 2. Like this, converting this into a string. What is string after this? Still convert dot and ASCII to integer I. ITOA is not a function actually. ITOA and define still convert. Do we still have the error? We don't. So that is nice. That is nice. And yeah, can we avoid doing this? This does not look very beautiful. ChatGPT. In Go, I am using the following statement for 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 a how can I make it more compact is not equal to this, not equal to this, equal to this small set of characters, then no, that is not something that we will want. Or use a string. Shit, why is ChatGPT writing in like literally reading speed? Okay, it is faster now. Use a map lookup. Use a string contains runes. Shit, that is good. 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 Shit, but the thing is now we have changed substitute this with nothing on the whole line. We have changed once and yeah, we have changed the type of cur. It is now not a character. We can actually make it a character as well. That might actually work. And we can now convert this into a string, I think, and yes, it does work. And here we can have that are normal. That is cool. And the function we can use is strings contains runes. If not, strings contains rune. What are the input types? First is the type, and next is the rune. A single rune we want. That does make sense. That does make sense. And the runes is cannot be 1, 4, and 7. Char cannot be 1, 4, and 7. If it is not 1, 4, and 7, then do this. Right, cool. And then case R, we have something similar. Yo, ATOI for ASCII to integer. Yeah, ASCII to integer, ATOI. And this is crazy. We don't have ASCII, we have runes, which is just an alias. So that is crazy. And shit, what is the type of this? This is also a rune. Okay, that's crazy. Okay. And shit, if we convert a rune into a string, what will happen? Land go. I think this will work. This will like work. Dd go and test dot go. So if we make this thing a 5 like this, and now do go build and everything, we do see a 5. That is much appreciated. Do 02 and that is cool. And if our string contains rooms are if not equal to 3, 6, and 9, what current value, then we can just do current plus equals 1. Contains room, then current equals 1. And then for case up, if not string contains rooms, if not equal to 1, 2, 3, then you'll have to see. Okay, so shared, then from we can just subtract 3 and it works. If we are at 5, subtract 3, we are here, subtract 3, minus 3, minus 3. Yeah, cool, works. Okay, shit, this is outside the statement. Okay. Then where minus equals 3 and case D, which is the default case. We are again outside. If not string contain rune, if not equal to 7, 8, 9, कर value, then square plus equals 3 and everything I guess checks out. Right, and at the end add the current value to the response and then print the response. That would be our answer, but there is an error somewhere. String convert, we are not using the string convert function. Okay, go build output out and part1 dot go dot slash go and 55555. We are either not changing anything or we got messed up. Let's use our test value. Instead of this, we will say, can we overwrite data? Let's block out this part and we will say this thing equals this. Okay, how do we write multi-line string in Go? Using backtick. Okay, cool. Backtick is the way to go. Substitute this thing with a backtick. Back. Uh, Substitute this thing with a shit. Why can I not write backtick? Shit, I cannot type backtick somehow. This is printing the rupee symbol. Wait, that is actually crazy. And cool, we are not using that. It's just a warning. Okay, cool. And let's see what this does. Go build and also part1 dot go, and then we want a new line. So print ln go dot slash out, and what do we see? 555. Okay, we are not actually updating the cur value. Why are we not updating cur? If a string does not contain, we are messing up somewhere. Let's see. Uh, empty dot println x print x. Let's see if we are getting x dot slash out, and that's not very good. Shit, that is actually not very good. We are getting x as a number. X as a number. We don't want x as a number. We want x as the thing that we are iterating over. Range lines bracket x. And C is also an index, and that should work, hopefully. That does work. 1985, that is the correct answer. This and this go run dot slash out, and the answer is this number 782933. Let's see. 782933. Okay. That is not the right answer. Your answer is too high. That is not the right answer. Our answer is too high. Or you could have used backslash. Yes, I was thinking working overtime. Yeah. And you, how the fuck are you able to write that? I don't even have it on my keyboard, and my laptop keyboard just has symbols. It doesn't. Okay, I don't know why it is going. Hello, how is everything going on? Yes, going, that could be taken as a pun. Yes, doing, we are going right now. But this is the wrong answer. Okay. This is the wrong answer. Our answer is too high. We can go to the subreddit if we want from 2016 and check out. And we are getting the wrong answer. 782933. 782933. Part 1. We do have the correct input. We are getting the right answer for this. Okay, and the document goes on to explain each button to be pressed can be your puzzle input is in the instructions from the document you found at front desk. What is the bathroom code? Begin with get your input from here. You can also share this puzzle. Okay. The 5 button. Start from the 5 button. Uh, we are doing everything correctly. If we want to go left, if the current value is not 1, 4, or 7, which is correct, then go to the left. And going to the left simply means subtracting the value by 1. Going to the left means subtracting the current value by 1. So that is correct. And going to the right means if we are not at 3, 6, and 9, we can just increase our current value by 1 and we will move right. 1 to 2, 2 to 3, 4 to 5, 5 to 6, 6 to 7 to 8, 8 to 9. That is cool. And going up, if we are not 1 to 3, then we can subtract 3 from the current value. That is also pretty cool. And yes, it checks out. Subtract 3, and if we want to go down, then if the current value is not 7, 8, or 9, we can just add 3. So 5 to 8, 6 to 9. That should work. And up, left, right, down. We did go through all the statements here. So this checks out, and string cur. And yes, this does check out. X and lines. It end of file. End of file. We might be missing because of end of file. Yeah, and here strings dot trim data. And what does this return? Not enough arguments. Huh? Remove space or yeah. Uh, trim space. That might actually fix things. Let's see. Okay, yes, we have one less 3 here. Shit. Okay. And the error was because at the end of the file we are iterating. Let's before that, yeah, that now it is the correct answer. Okay, so what was the error? The error was part1.g gg. The error was this: data is read from the file, and at the end of the line, at the end of the file, I don't know if we do have a new line, but does not matter. Even if we do or do not have a new line at the end of the file, we will create a empty string at the last index of this lines variable. So, and that was messing things up. That is why we were going through this lines variable one more extra times and one extra time. And even though we were for that extra iteration, we were not going through this loop. We were adding the same res cur value again to the response, which was 3. So yeah, now it is fixed. Now it is fixed. We have removed that extra byte from the end. So that is cool. And also here X is going through the indices of lines. We don't want that. Can we iterate by value, like something similar that we do in C++? iterate by value in Go for a array. We can create a vector whose name will be an array. That would be like crazy. Okay, index and the value. Okay, we can discard the index. Yeah, that is cool. And index and value. That is cool. Go slash out, run, and the same answer. That is cool. Now moving on to part 2. Okay, part 2. Shit. Shit. Our numpad has changed. Shit. It was like this and now it is like this. You finally arrive at the bathroom. It is a several minute walk from lobby, so the visitors can behold the many fancy conference rooms and water coolers on this floor and go to punch in the code. Much to your bladder's dismay, the keypad is not at all like you imagined it. Instead, you are confronted with the result of hundreds of many hours of bathroom keypad design meetings, which is this. This is the keypad where we have to input the answer. You still start at 5, okay, and stop when you are at an edge. Given the same instructions as above, the outcome is very different. You start at 5 and don't move at all up or left or down since both are edges ending at 5. Continuing from 5, you move right twice. Right, we go to 7. Right, move right twice and down 3 times. 3, we go to D. Okay, through 6, 7, B, D, D. 6, 7, B, D, D. Okay, ending at D. Then from D, you move first 5 moves through D, B. We cannot move diagonally. Okay, so we just have to incorporate this thing. Given the actual layout, the code would be 5D B3. Let's check if that is what we do. Part 2 dot package main and a multi-line comment like this. Cool. And we can just copy. We will not copy. We are programmers. We will write everything from scratch. Check before check. Import FMT and OS. I don't know what the other packages are which we will be needing. Then check, which we don't actually need, but okay. Check does takes in an error, doesn't return anything. And if E is not equal to nil, then return panic with E. Not return panic with E. Just panic. Okay, this is not C++. It is declared and is never used. Redeclared, redeclared, red. Makes sense. Makes sense. Shit, that does make sense. That does make sense. Okay, and here we'll have data and error from equals os dot read file, and let's turn off the lsp and see how do we do dot slash x dot txt, and this thing is not the suggestion that I got just now was not from the LSP, it was from another plugin. Okay, and then click E, and we have no indication whether we are going through some error or not. And now we need the lines. So lines equals strings. We will need to import strings, and I think we should turn on the LSP. Yeah. Strings dot split. Yes, strings is also imported now. Split what? Strings dot trim paste string data and split at new lines. Undefined data. Walrus. Declared and not used, that is completely fine. And we will say current equals 5 and response equals empty string. And for x underscore, which is the index, and x equals range lines. And yes, for underscore c in range x. And now how do you see? Switch for c is L. Okay, what are the values where we cannot move to the left? From 1 to 5 AD, we cannot go to the left. And if it is none of those, then we can just -1 and it works. Yeah, that would be handling the left movement. That's cool. Okay, you can buff you for read. Buff IO for reading, it automatically handles end of file. That is cool. That is because you have already declared it in other Go file. Yeah, I messed up. There's the package level in Go function. Yeah. Shouldn't use this instead of this. You simply use equal instead of walrus. I know that's not clear that, but come on, Python was my first language. What do you expect? Yeah, never mind. Yes, and walrus. Yeah, walrus operator. Okay, if L and case L, if we are not equal to strings dot contain runes, which string we cannot be equal to 1, and but I need to see this thing. We cannot be equal to 1, 2, or 5, or A, or D. Should 125 AD, 125 AD. I don't know what happened in 125 AD. That is too long ago. If cur is not equal to any of these, then we will do cur -1. That is case L handled. And for right, if string dot uh, contains runes, if I am not equal to 149 CD. CD is not a historical term. CD is a compact disk. If cur is not equal to any of these, because we are outside. My bad. What can we just increase by? We can increase by 1. That's equal to 1, and then case up. Shit, we are again outside. Case 1, if contains rooms. If up, we cannot go up if we are 1, 2, 5, 4, 9. Yeah, 1, 2, 4, 5, 9. Yes. Otherwise, we can go up at the end of this. Plus equals print line less. And okay, if you want to go to up, what do we do? There is not a single value that we can just subtract and it works out. If we are at 3, we will go to 1. If we are at 6, 7, 8, then we will minus 4 and it works. But if we are at A, then we go to 6. If we are at B, then we go to 7. If we are at C, we go to 8. We go to 8 and we will face the same problem when we are going down. Like there is the obvious way of doing this and checking where we are at. If we are at 3, then we can go to 1. If we are at 6, 7, 8, we can use the contain rune function for checking. If we are at 6, 7, 8, then we will just minus 4. If we are at D, go to B. If we are at B, A, B, C, then we can have 3 statements. If we are at A, B, C, I think there is a smarter thing that we can do instead of checking for A, B, and C individually. And that would be capital A or current value minus capital A. Current value would become equal to 6 plus cur minus capital A. But yeah, we will have to write 1, 2, 3, 4 if statements. Yeah, let's see if cur equals 3. If cur equals 3, if we are currently at 3, we will cur equals 1. And this is very lame. I don't really like this. This is very, very lame. And else if should we do else if else if mm, okay, we have to write here not contain, and here if contains rune if we are among if we are among 6, 7, 8, then we can just do cur minus equals 4, and then on the same line else if strings dot contain if this thing contain if we are at A, B, or C, A, B, C, then cur equals 6 plus 6 plus cur minus 6. Yes, cur minus A, cur minus A, and else if we are at D, else we don't even have to check if cur equals D. Yeah, this does not look very good, but I guess. Cool. Should we are again outside? Case D. Uh, if you want to move down, we cannot go down if yes. Strings dot contains room. If we don't contain the values 5, A, D, C, 9, if current is not equal to any of these things, then we will do some magical stuff. And that is, we have to do again the same thing. If per equals 1 literally, then per equals 3, else if current value, no, we will use the strings dot contains room. If this thing contains what? If we are among 2, 3, and 4, we will just add 4. Yeah, per plus equals 4. Else comes on the straight line, on the same line as the where we end the previous if. Yeah, else will come at the same line where we ended the curly bracket for the last statement. Strings dot contains rune if we are at 6, 7, 8. Strings. If you are at 6, 7, 8, then cur becomes equal to capital A plus cur minus tick. Same line, same line. Else cur equals. Think I messed up completely. No. Else cur equals D. Yeah, we are moving down, so that is cool. And yeah, way down we go. Everything seems to check out. Go build output part2 dot output out part2 dot go and dot slash out and dd. Shit, I guess we messed up. I guess we kind of messed up. Let's do the testing code. Let's say data equals backtick is something we cannot use somehow. As someone said, shit. Uh, go dot slash ACBD. That is not the correct answer. I will have to go to the washroom. I'll be right back in a minute. I'm not sending messages now. Okay, it is taking too long, I guess. YouTube deleted same comment twice. I don't know why, even though I was even just explaining shit. Moderation activity, I guess, would do some help. Yeah, I'll be right back in 1 minute. Washroom. And I'm going to be back. I guess YouTube is a hater. YouTube just hates. Okay. Bathroom code. Okay, this should have been the correct thing. ADB3 ACBD is what we got. ACBD is what we got. Okay. 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 ACBD is what we got. Part we got. Go up, up, up. If we have up and this shit. Yeah. 5 dB3. 5 dB3. Yeah, cool shit. Go part 2. Google dot slash run and AC8 C8. Shit. No, I will not use the mouse. Go back here. Vimium AC8 C8. Submit and and that is cool. That's cool. That is cool. Yeah, me special haters. Yes, YouTube is a hater. And with status. Okay, laptop is going to die. Yeah, phone is charged. It was literally going to die. Okay. Get the status and we deleted a file and untracked. Get ignored. Yes, our own custom get ignored. Oh, no, it is not talking about that. Yeah, that is cool. And move everything from day 00. I don't know why there is a day 00 to day 01 and unless day 00 everything is gone. RF slash nope day 00 and it is status everything is amazingly cool. Test parser.txt. Then day 2 and the first audition number 16 that is working and now on to day 3 I guess. I don't know code. 12 days for the actual challenge and also there is some change in advent of group. There will be I think 12 problems this time. Total stars 120. Let's go. I think there will be 12 problems this time. Yes, it takes ton of time. What is the number of days per event chain? Yeah, so I was unable to understand what this paragraph means, but my understanding was they are changing the number of problems. Netlib. What is netlib? Network library. Mathematical software. I do know a little bit of latex for note taking. मतलब repository, browse, search. What is this for? It is a collection of tools, part of the standard Go library. Okay. I guess step by step, I just started Go. This is like my day 4 of learning how to write Go. 4 days ago, I didn't even know what package main means. I still don't know what package main means, but yeah, I have a partial understanding of what it means. So yeah, step by step. We did user input errors. Let's read a bit more. Yeah, loops. I have no idea what is loops. Initial condition after that school, the basic loop in Go is written in a standard C-like syntax without the brackets. Initial condition after, yeah, cool. And next, omitting conditions from a loop in Go. Just omit the thing. Loops in Go or shade. There was also a free reader, like voice button here, which would read the content of this page, but it is not here because we are in guest mode. Loops in Go can omit sections of a for loop. For example, condition middle part can be omitted, which causes the loop to run forever. Assignment, nope. We will do our own assignment. There is no while loop in Go. Shit. So we for condition do some stuff. Okay, that is crazy. For this, there is no while loop. Should we are omitting the initializing part and the incremental part, both the things at the same time. That the net HTTP and system of Go are standard lib Go. Are standard library. Shit. Okay. Not that. The net slash HTTP and such library of Go standard library. Okay, I'm just stupid, I guess. I started with netlib. I wanted to build a simple server to test one of my code. Shit, you wanted to build a server to test one of your code. That is like, I don't like Windows. I will write my own operating system mm, to run operating system because I want to like watch a movie on operating system. I will write my own operating system. I don't like Windows. Most programming languages have a concept of while, but we don't have while. Go allows for the omission of Rust. Also does not have a while loop. I think it has loop. It literally has loop. A word named loop. That is crazy. Sections of a for loop, a while loop is just a loop which has only a condition. Yeah, cool. That does make sense. Okay, what have we read till now? Fizzbuzz. That is what we want. Fizzbuzz. Let's actually write Fizzbuzz. Fizzbuzz is cool. Fizzbuzz. Fizzbuzz is actually cool. Yeah, Fizzbuzz is cool. Let's write the best implementation of Fizzbuzz. Fizzbuzz.go. Package main. Punk. Mm, are you sure? Shit, they are very sure. Fizzbuzz. I.go. There is no go statement here. Mm, Fizzbuzz.go. On main and no packages. Okay, function Fizz buzz that doesn't take in anything. It yeah, doesn't take in anything. It returns by string. Yeah, does take in a integer x. And response equals this if or let's can we have a map in Go? That would be nice to have a map. Look, like template function that knock shit. You know about anonymous functions? Yes. Yesterday we were reading out anonymous functions. That was cool. So, no shit. Cool. I like the template function of Go, where you can add in the website build your own game engine if you are a real game developer. No shit. Nope. I'm not a game developer. I would use Love 2D. Love 2D is nice for Lua programming. Bellatro is written in Love 2D. And yes, also there is a game which is written. Okay, of course, Bellatro is written. I've not never played Bellatro, but it is supposed to be a very nice game. And this Oh My Giraffe game, this is very cool. Their website is very cool. Look at this. If my mouse goes there on the side, the giraffe goes away. Like, this is very fun. The giraffe goes away whenever my mouse goes there. That is like actually fun. I can do this all day. The giraffe goes away. That is just so fun. Okay, Fizzbuzz. How to make map. Go maps in action. Let's see. Yo, what do you have to call me out? You shit. People are fighting. Yeah. You are certified. When to nice to know that is our 2D girls are the best. Shared. Um, Queen, Princess Peach, I suppose. Make map string to value. Map key is integer, value is string. Hmm? Expected declaration found MP. Or this takes in MP, which is a map which has integer keys and string. No package is found. That is fine. Shit, this thing was not charging until now. Okay, it was. Uh, okay, here we will make our map MP equals how to define key value pairs, not like this. Hmm. Hmm. At the time of the declaration. Hmm. Go at the at declaration. Okay, that is cool. Like this makes sense. Okay. And map integer string 3 is fizz and 5 is buzz. Declaration and not use, that is completely fine. Should map is just a structure, it seems. Okay, we'll call the fizzbuzz function fizzbuzz and give it some for I equals 1, I smaller than 15 equal to 15, I plus plus. We'll do print I, right, print ln I, comma, whatever fizzbuzz says about I. Not enough arguments. Yes, that is true. MP does check out. That is also cool. And yes, now the main declare thing here for key value in MP expected Boolean. This is how they were iterating over a map for key value in range. And yeah, cool. If x mm, if x remainder with key rem, remainder with key equal to 0, or can we say if like this? Yeah, we cannot. We cannot. If this thing equal, why is the LSP so bad? Anyways, plus equals value, and yes, that is fizz buzz. I think that is a good implementation of fizz buzz. We can even say 7 fizz buzz zazz. Go build output out fizzbuzz.go / out and yo divisible by nothing fizz buzz zazz. Fizz buzz zazz makes sense, and the first number 3 into 5 15 into 7. What is 15 into 7? 15 into 7 would be 90 75 105. Let's go till 105. Just add a little bit of 0. Zaz fizz buzz. We are starting with Zaz. Order of map is undetermined. That is a discovery, I guess. Hello. Bro, how much time will it take to get from 1000 to 1400? I feel like I wasn't progressing much, so I paused and starting working on project. Where are you learning? Go from. Okay, for theory part, I'm going with this thing, and like this is just memorizing because I'm unable to practice what I've learned from this. But for practicing part, just this advent of code. Go to advent of code and do some problems on advent of code. That is what I'm doing. 2016, and yeah, that is cool. And what else? For progression from 1000 to 1400, I guess read theory from CP handbook, right? Read theory and do problems. That would be, yeah, that is enough. Just read and understand theory and do questions. That is cool. And fizzbuzz. Let's add one more thing. Now this is cool. This is cool. Enough prime numbers. Instead, all of these numbers where we have empty, all of these numbers are not prime, but these are not divisible by 3, 5, and 7. So they themselves are prime, or they are factors of prime numbers which are higher than 7. Okay, it was then count and break, which is like last. Continue and break. Yeah, continue and break is very generic. Break makes sense, and continue also makes sense. Anyways, wherever you want to change the control flow of a loop, we use continue and break. The continue statement, yeah, the continue statement stops the current iteration of a loop and continues to the next iteration without executing all the remaining code. Continue is a powerful way to use the guard clause pattern within loop. Guard clause. Did we read about that guard clause? There are even blogs on Boot.Dev that is slow is smooth, smooth is fun. That is written by 22. Who said this? Move this fast. That is a song. Shit. 2025. No, who first said this thing? Yes. Apparently, we can thank the US Navy and the SEALs for the exact wording. Although Napoleon is quoted to tell his warlord that dress me slowly, I am in a hurry. Shit. Napoleon was a genius. Dress me slowly, I am in a hurry. Shit. That is messing up with my head. Dress me slowly, I am in a hurry. That is actually hurting my brain cells. This is statement. Anyways, continue and break. These are generic things, makes sense. And connections. Okay, this is a exercise, I guess. Connections. TixU has group chats that make communication with multiple people more efficient if the chat doesn't descend into chaos. Instead of sending the message multiple times to individual people, you send one message to all of them at once. Yeah, whatever the assignment is. Moving on, we understand loops. Now on to slices. Slices are also there in Rust, so that is cool. And the next thing is map. Yeah, map is what we wanted to know about. So that's good. And for Go, I would say there is the obvious book, the Go programming language by Brian Kernighan and yeah, Go programming language by Brian Kernighan and I don't know this person, Alan Donovan. Let's yeah, he is 49 years old, square of 7. He has his website .net. Shit, that is too much white. Okay, Go team and Google. So, okay, co-author of this book. There is nothing here right now. Shit, bro has not updated his resume. Yeah, this book is nice. You can go read this book. I have not read this book, but yeah, this book is nice because this is by Brian Kernighan. That is all the validation anyone would need. And on to arrays in Go. Yeah, arrays are fixed size groups of variables of same type. For example, an array of 4 strings makes sense in an array of 4 values. Okay, where would we like to use an array? We can declare an array like this or an array like this by giving the values at the time of the declaration, and this seems to be a generic format. Here internally we are telling how much and then the type instead of what we would. Okay, so the type always comes later towards the right in Go, no matter where we are. Okay, and that since functions in Go are high order functions or first order functions, they act as values and we can take functions as inputs and also return functions as outputs, and also those functions which we return as output, they themselves can take in or pass out other functions as input or outputs, and those functions can do the same thing. So that is cool. Auto declare an initialized literal like this, that is cool. Okay, arrays. Let's do a little code forces and Go. Let me also say here, not stream health analytics, stream settings, Boot.Dev and admin or code. Let's go. That is nice. Analytics. Cool. And we'll do some problems here. Let's say 1200 because I don't want the difficulty of the problem to be a difficulty. I guess we can go for, let's try 1200. I don't know. Set out strangers. Okay. You are given a table of n and m columns. Initially, the cell at ith row and jth column has color this a, I, j. Let's say the two cells are strangers. If they don't share a side, strangers are allowed to touch corners. Let's say uh, okay, strangers are allowed to touch corners. Let's say that a cell of that, let's say that the set of cells is a set of strangers if all the cells, let's say that the set of cells is a set of strangers if all the pairs in the cell are strangers. Let's set with more than one cell. Sets with no more than one cell are sets of strangers by definition. Okay. In one step, you can choose any set of strangers such that all the cells in it have the same color. All the cells in it have the same color and paint all of them in some other color. You can choose the resulting color. What is the minimum number of steps required to make the whole thing have the same color? Okay. The number of distinct colors at least, and then if two things are sharing a border, then that, yes, yeah, we'll see. Yeah, so the minimum answer would be that. um, yes. Okay, 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 we got this. Fizzbuzz, no, this is not Fizzbuzz. MBDIR code forces or CF, CD, CF, N, come on, U3. Shit, I have not added Go as a thing here in the plugin. CBP wall update, CS, and no plugins, assistant in UM, and let's add another language. Let's copy this boilerplate. Go, and extension for Go is Go template nil. We don't even have to specify. The compiler is Go, and arguments arguments would be this. First, we have to specify. Yeah, first we have to specify what the output name would be and how can we give in the command. There is also a name we can by which function by which we can give the actual command. Compile. Main thing is this. Go build. Go build this and then run that file there. That's cool. That is cool. Yeah, that is cool. Checks out. .go is the extension. Yo, that sounds very wrong. Shit. Bro, JavaScript first working prototype was built in just what I've heard, it was like 5 days by Brendan Ike. How many did Ian Brendan Ike took to make JS and 10 days. Okay, shit. He worked hard for 10 days and on the 11th day he rested. That is how his workflow was. And can you answer my question again with Wi-Fi died for a bit? Shit. Okay. For theory, what I am doing is I'm going to this thing, Boot.Dev, and I'm practicing on Advent of Code. But I would suggest you can go through the Go programming language book. This one. And this is pretty cool. This is by Brian Kernighan, and he is a very good writer. He is a amazing human being, and yeah, his books are amazing. You can read this book. Solving a study contest. Shit, I'm not solving a study. Go Lang, yo, let's go. Rah. That that is white mode, and it will be like that. Let's go and end the file. Yes. Let's also define a boilerplate for Go. CPP boilerplate, Rust boilerplate, yes, similarly. Go boilerplate dot go package main package main. This won't even compile. Yeah, package main func. Okay, Go is strange. Go is strange. Go is strange. Best package main main and function main and yes, let's see how the things are. T, we will take this input. How do we take input from the standard input in Go? How to in Go? FMT scan. Yes, we can use the basic functions. T equals FMT dot F percent D into set. V equals that does what? That is writing forcing C++ on Go or C in Go. But is it even possible to progress? That is how you feel. That is how you feel. Not even background, everything changed. I am in a storeroom now. So, yes. Yeah, that is like always there. I also feel dumb. Okay, this is not Go specific. This is C. So, we are not learning Go by writing this. Let's do the same thing. How to take input from standard input and go. From 11 years ago using FMT scanf, scanline, or scanline using buff.io. This was the suggestion above. I'm so happy for the language that don't change after every version update. Yeah, C++ is like that. Kotlin destroys its devs. Shit, bro is actually crying. Buff.io, 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 buff.io. New scan from standard input. This looks good. We get a scanner. Should this is like Java. This is actually like Java. Enter some text. Scanner, scan, read the line, get the text into the line, and this is a string. Scan F is much better because we get formatting. We get T as a integer, so that is cool. And for T greater than 0, t minus minus func solve, and what do we have in the input? We have n and m, and then n and m. Okay, n comma m 0 0 declared and not used. That is fine. fmp dot scanf %d comma n address of. I don't even know if this is giving the address of n or m. nm, we know nm. Now we will make our array. Can we make a array of variable size? Let's see. A 2D array. Grid this thing size would be n, and then what it will have, um, invalid array length nm. Yeah, makes sense. But if we were to make these, yeah, declared and not used, so we cannot make variable length array, which is a true statement. Java is goated because we don't have to write static void main 100 times. Shit. Um, Yeah, yes. That is why usually Java devs are one of those go to, which go to go. So we need a data structure. That is cool. Shit. Slices, interface, loops, maps, pointers, channels, mutex. Why are they not talking about that? Array in Go, variable length array in Go. How do you create a from 9 years ago? In Reddit, people are learning Go on Reddit. Dynamically initialize array size in Go. Int slice. Okay, so that is the exact thing that we were going to read. Slices in Go. Shit. Okay, let's see. Make integer array and put in nothing. Append append to numbers this, append to numbers this. But we do know the size beforehand, so it's not very cool. Make make let's make something out of this. Equals make this first. This will have integer. Yeah, I'm just making things up now. Int comma n m. Make is not a type. Makes sense. Declared and not used. Is that the problem? For I equals 0, I smaller than n, I plus plus. For j small j equals 0, j smaller than m, j plus plus. And fmp scan f into give address scan a dig. Or we could read the whole line and split the line on. Yeah, sure, we can read the whole line, scan line and split, but still we would have to go Hmm. Yeah, I guess you can read the whole line. That would be a bit faster. Scan, how do we read the line? Scan line, no, scan line, and put this into ln equals, what does this function require? This takes in nothing. So hopefully we will get the line inside this and not see out. Print ln line. Check. Okay, we are even not even able to compile. Go. Shit. Go. Build out. Out. Best. Build out. B dot slash out, and it is asking. It is asking for it. It is actually asking for it. 4. Let's give the input step by step. Yo, scanner. CPP is actually goated. CPP is like very convenient. You can create a whole language in CPP. That is very convenient. And I used to love coding. Shit, bro's too old. Unk 1 1. Okay, it is actually taking an input. That is kind of, it printed empty line. This thing printed empty line. Go scan line. Key characteristics reads until new line. That is okay. And space separated values, it parses the input based on spaces, assigns each separate space value to the corresponding variable in the argument list. In the argument list, we will provide an argument list. Shit. Okay, that is ah. I guess we will go line by line, and not line by line. We will go not fizz buzz, character by characters. Uh, J equals 0. J is smaller than M. J plus plus. And here, where is the grid? We need the grid equals make n comma n. Scanf read the current digit into grid I j, and that is very cool. Println, can we print a grid? We can actually print a grid. We can print the whole grid in one go. In one go, yes. Let's go. Go build or slash out input this whole thing. Shit, this might actually be dangerous. too many arguments. Go runtime index out of error range. Uh, okay, we went out. Run this 411. Go runtime index out of error range. Out of error range. So the make function is not working fine. This thing does not work. ChatGPT, or how to declare a 2D array in Go with variable size. Initialize a 2D array in Go with variable size rows equal to this int rows, and then go individually to the whole thing and make um, yeah, well, I equals 0, I smaller than n, I plus plus. And I'm not looking forward to optimizing this and doing this in the best way possible. I'm just doing this. Yo, where did you learn C++ from? A book or website or just not college? Uh, just college branched out. No, not college. It was the C++ programming language. The book by Mr. Pian Stroustrup. He is the guy. If you want to learn C++, then he is the guy. And this is the book. And this is very daunting because, yeah, this book is very daunting. But I had to go through the introduction a few times, like 2 to 3 times, and then I understood a few things. Yeah, this is a very cool book. You can read the introduction part, the basic facilities, and I didn't read the abstract mechanism, but yeah, I read some chapters from standard library. That is all, and that is cool. And also some tricks. I discovered some tricks by reading code written by Jiang Li. Jiang Li is amazing on Code Forces. Nope. Yes, it is a reference book, but I am stupid and I read it as if it is a novel. But I think that was a good decision. Grid I equals make, and yeah, at least you can read the introduction part. That is cool. Yes, please give disclaimer before recommending this book. Not for weak hearts. Yeah, that book is pretty cool. That book is really good. And now there is uh, C++ 17 complete guide PDF. This book for understanding the new things which were added in C++ 17. And then there is also the C++ 20 part, which is also written by this guy. I haven't read this book, but yeah, this is the book that I will be reading now after Go. And yeah, yeah. And I think, now, yeah. 4 1 1 1. Huh? We are printing the shit. That is correct. We printed one. I think that is how grids are. Okay, shit. This is telling us the size, I think. That there is a 1 by 1 thing at this index. So, shit. And let's go. Okay, have you read a tour of C++ or do you recommend? It for a programmer with experience in C, Python, and JavaScript. I guess I haven't read the tour of C++, and the specific book which you might be reading for getting started with C++ does not matter. What matters is just choose any book and start reading. Right, that will help you. Yeah, so the specificness of the book does not actually matter. Just choose any book and you are cool. Let's see. Oh, and let's see. Let's see is also a book. Four, one, one, one. Why are we seeing this? What are the next inputs? 3, 3. Yes, paste. There is no problem. And this is saying we have a 3 by 3 things, but why is it saying it twice? Somehow it is saying it twice. No, no. Let's solve it. Let's suppose that we are getting the correct grid and solve, or shit, we can check it here. T dot print grid I, J, yes, and here fmt dot print new line, or even this. That is cool. Let's see. Go run. We have one test case, which is 3 by 3 matrix, and the numbers are 1, 2, 1. One, we do see 1 to 1, and we do see 1, 0 somehow. Shit, yes, we see 1, 0 after 1 to 1 because the ASCII code of new line is 1, 0. So yeah, that is not very good. Substitute this with this. And also, okay, this is just for checking, and if I was in an actual contest, I wouldn't be getting too much into this, but I'm learning this language, so this is cool. This is cool. Messing around with the language. Here, after this, we need a space. Space. Yeah, cool. Go slash out. One test space, 3 by 3 matrix, 1 to 1, 1 to 1. That is what we get. And then 2, 2, 3, 2, 2, 3, 2. That is what we get. Then 1, 3, 1. That is what we get. That is cool. Okay, we are getting the right thing, hopefully. And our hope is stronger now. Okay. After this, when we have the input, yes, shit, now is the actual problem. NM700 value is between N M, and for every color that we do see, we need to know three things. For two things. One is the color present, and second, does it have neighbors? Okay, we will not do that while we are taking the input. Best book or resource or for data shit. That is the thing. Best book shit. Don't look for best, just take anything and it would be good. And yeah, yes, these two are very good recommendations. CLRS is very good, and CP Handbook is also very good. And red question mark is cool. CLRS, this book. CLRS because CLRS, the authors, and Introduction to Algorithms. And this is very comprehensive. You do not have to, and it would be very difficult to understand everything that is here in this book. So don't feel bad if you don't get anything in first try. Yeah, this is the book you can use for comprehensive in-depth knowledge. And also there is the PHB, C Competitive Programmers Handbook, which you can go and read. Yeah, that is also cool. And yeah, it's cool. And now for the actual salvation. We have our grid. We need to know which numbers are appearing and what are their values. Which numbers are appearing and do they have a, like, is there an instance where that color which is there shares an edge with the same color, like here, this thing. And yeah, we need to know that for every color that does exist. We can store this in a map. That would be nice. We can store this in a map, and if a color does exist in the map, that means the color does exist in the grid. So the size of the map would be how many colors there are. That would be the minimum answer. And then we'll go through all the colors and we will choose, or we will see. Yes, we will not choose, we will see. We will see how many colors are there which share edge. Like in this, we have in total 6 colors, 1, 2, 3, 4, 5, 6, and all of them share an edge. So no matter what color we choose, like if we choose 4, right? So we will have to use one operation for this. Minimum answer is the number of colors, distinct colors, minus 1. That is the minimum answer. So here the minimum answer is 5 because there are 6 colors. So the minimum answer is 5. 6 minus 1, 5. Because we will choose one color in which we will turn all the other colors into. And yes, let's say we choose 5, then there is this color 1, and all of the instances of 1 cannot be chosen in one go because this shares an edge, right? So that is not very good. That is not very good. Yeah. So we will have to do 2 operations on this 1, 2 operations on this 4, 2 operations on this 2, 2 operations on this 3, and 2 operations on this 6. That is in total 10 operations, which is the correct answer. And yeah, that is it. But I meant for like starters, okay, like array, stack, queues, linked list, and so on. The ones you told were like advanced as shit, EF, okay. Yeah, I guess yes. The C++ programming language, that is, yeah, that will scare you or anyone. So for this, I guess, if you want to understand basic programming concepts in general, then CS50 is a nice thing you can go through. CS50. This is a course by Harvard, and yes, promotion sponsor, official sponsor. They are the official sponsor. Harvard is the official sponsor of this channel. You can go through this course, and that is pretty cool. This is for beginners, Introduction to Computer Science. And I guess after this course, you would be good enough to be able to read the C programming language. This book, this is also by Brian Kernighan, and this is much more simpler than its C++ counterpart. C++ is complex. Before starting with C++, you should start with C. And this is the book, a tutorial getting started, the for statement, symbolic constants. And there are also exercises in this book and they are difficult. So yeah, they are challenging. These are basic codes and then exercises. Run the hello world program on your statement on your system. Experiment with leaving out parts of the program to see what error messages you get. So yeah, this is cool. This data type dynamic in Go. Data type map is dynamic. I haven't seen any other data type which is dynamic in Go. I mean, yeah, I don't understand the memory management yet in Go, how it goes in Go. Okay, we will use a map for this. MP equals a map, a map, a map, where the key is an integer and the value is also an integer. And shade, whenever we are using the make thing, that is dynamic. The make built-in function allocates and initializes an object of type slice. Shit, we were like just at the cusp when we switched to code forces. Slices, map or chain only. This is not chain, this is chan. Shit, that is Japanese. Chan only. Like new, the first argument is a type, not a value. The first argument is a type and not a value. And the second is how much do we want of that thing? Share how much we want of this thing. So that is like allocate malloc. That is like malloc. Give me this much of this thing. Okay. This is the type. An array of integers. Shit, now this makes sense why this thing would not work. Okay, we have the map, and then I think we can create the map. We'll go to the loop after this. Yeah, for int. No, without the bracket. I equals 0, I smaller than I plus plus, without the brackets, equals 0, j smaller than n, j plus plus. Ah, okay, we have to see, have we seen this thing in the map before? How do we see if our key exists in a map? If mp dot key exists in a map in Go. Shit. Say for non-existence, break up the thing. We don't actually need the value, we just want to know if it exists, or we do need the value. We do need the value. You also need to know. Yeah, okay. So map for grid I, j. Okay. If okay is not equal to nil, okay is not equal to, okay, what is okay? Okay is not error, no information available. Shit, there must be information now. Okay is bool. Okay is bool. If okay, then yeah, if this value does exist, then this. If the value does not exist, okay, if the value does not exist, we will just say mp grade I j equals 1, and let's say mp for some value x equals 1. 1 would mean touch edges, and mpx equals 0 would mean not touch edges. Okay. Value. If value does not exist, then something, something. If value does not exist, delete this part, delete this. If value does exist, and also if value does exist, and also if value does exist, and the value is okay, we messed up our statement. Okay, and now we will be here if there is no value, or if there is a value but it is 0, then we will go in the fourth dimension. We'll go in all the 4 directions and we will see if this number is sharing an edge. Like if we assign a variable to a int type, then can we assign it a string later? Is data type dynamic? Okay, no. It is statically typed. Statically typed. Like shit. Shit. I have not written any type while declaring variables because we have this thing, walrus operator. This operator checks what the value is and auto assigns. Like, yeah, type inference is happening, but the types are there. Okay, if we are here, then we will go in the all of the 4 directions. Let's directions equal a map. Yes, I'm making this more complicated because we are learning uh, an array of an array, an array of an array of integers where, right, array of integers, right, right. Here we have an array of integers which has -1, comma -1. Expected declaration found direct. What is the problem with having directions? Declared, not used. Okay, so the syntax is correct. The syntax is correct. That is very cool. This thing, then another -1, -1, -1, comma 1, comma, and 1, comma -1. There has to be one more comma here, I guess. And then n 1, comma 1. That is cool. And here we will go through. They are comments. Here we will go through the values. Can we go through the values? We cannot go through the values. We can go through the values. For we don't need the index, we need the directions. Let's call them x. X is the direction. In range direction. X is not being used. Yes. Now x is a array which has 2 values. Yes. Let's say dx delta x. Okay, let's use d instead of this. Delta x comma delta y, they are equals d0 and d1. Declared but not used. Yeah, that is fine. That is fine. Declare that. That is fine. Now, nd or nx ny would be equal to dx plus the change in x plus the current x, which is y, and the new y would be equal to change in y plus the current y plus the current y. Now we are not using nx and nx and ny. Now if nx and ny are in the range, which means nx greater than equal to 0 and nx smaller than equal to, instead of x, let's use I and j, substitute x with I on the whole thing, and substitute y, substitute y with j on the whole thing. Right. This is smaller than or equal to strictly smaller than n, and n j is smaller than equal to 0, and new j is smaller than n. We are within the range, and at that place, if grid ij equals if if grid I equal grid ni and nj, we will say that mp grid I j equal for. That is very good. Okay. Okay, that is good. And now we will go through the map, for which, yes, we will go through the map for which we use the for loop, where key and value in range map, right? Key and value in map. Response is mp dot length mp dot print line response, and then okay, response is minimum. The minimum response is the length of the map. Now, okay, now. Length minus 1. Now, for extra operations, shade. Okay, and if we do this, then we will range out of this. Yeah, we will break out here and here. Let's say mp grid I j equals 0. That is the default value, and this is 1, and we are only adding 1 once. So we don't actually have to go through this key value pair. No, we don't have to. We can here, that is extras equal 0, and whenever we see this extras plus plus and the extras plus plus and break, and response is not equal to this, response is this. Response equals size minus 1. That is the minimum answer. Plus the walrus operator, size plus 1 plus, do we have a ternary operator? Go. Shall guess not. No. We will have to use if else. We will have to use if else in Go. Size minus 1, and if extras, if we have three colors and two of them are repeating, we can choose the third color as the final color. We can choose the one that is repeating as the final color. 1, 2, 3. Answer would be minus 1. Answer would always be extras minus if extras not equal to 0, then this plus equals extras minus 1. Yes, shit, I think that is correct. If extras is not equal to 0, the answer is extras minus 1. We are saving one operation, and that is all we can do. We can only save one operation. I think we should be good. We should be good to go. But slash out, we have just one test case. It is a 3 by 3 matrix, which are, to be honest, this. Yes, no problem. 2 is the correct answer. Shit, let's go. And for this 3 by 4 matrix, then test case 3 by 4 matrix. Yes. 5 is not correct. Should we can save this? Okay, that is quite nice. 5 is not correct. So extras is always equal to 0. Extras is not increasing, which means we are not getting in here, which means we are not, this thing is never true somehow, or we are not calling this condition because of this. But we are getting the directions. Changing I, changing T. Yeah. Println and I, comma, ng. Go build dot dash out, and we have just one test case 3. Dot dash out dot slash out one test case which has 3 by 3 columns 1, 2, 1, 2, 3, 2, 1, 3, 1, 2, 3, 2. The values are almost never in range. Answer is coming out to 2. print ln map go or slash out one test case. It has three things and 1 2 1 and 2 3 2 is 1 3 1 map. We are saying 2 is appearing 2 times, which is not very good. Extras is equal to 1, so that is good, but that is not actually good. Why is 2 appearing 2 times? It is 3 that is appearing 2 times, not 2. And B, okay. 2 is not appearing 2 times. 3 is the one that is appearing 2 times. So, like, shit. Okay. Shit. Yes, makes sense. Makes sense. Directions are wrong. Directions are messed up. At one time, we are only moving in one axis. Shit. 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 That was the problem. And yeah, that was the problem. And so build dot slash out. We have just one test case, which is 3 by 4, and the things. This is the 3 by 4 configuration. Yes, go on, paste. Answer is 10. That is the correct answer. Just in case. Or slash out, one test case, 3 and 4 numbers, 1 4 2 2 1 4 3 5 6 6 3 5 10. Okay, it would be funny if 4 forces says we cannot submit and go. See, paste and go. Let's go. So there are no versions of Go, just 1.1, and hopefully in Q. Yes, shit. This might just stay like this. Status, 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 status. Friends only, my only. Shit. Dominator, my friend, is having some trouble with this question. And my only. Yeah, yeah, yeah. Yo. Regionals, it was cool. It was actually pretty cool. It was my first time giving ICPC, and I like it boosted my confidence. I did 4 questions. I was not doing it seriously. I was just checking out how things are going on. But yeah, there was one question which was an implementation of convexel. That was cool. And in one question, I applied Dijkstra's algorithm. That was also cool. Yeah, the B question. Yeah, B question I didn't do. Yeah, my friend was working on it. The system testing for test on 14 was stuck on 95% for 6 hours. Shit. I don't know. This has like only started happening lately, which is crazy. On 14th. This one. And this was also educational round. So shit. Educational rounds are crazy by themselves. This thing, and look at the rank. There were only like 700 people, so the rank is not very impressive. Mm, shit, you were also there. Yes, you were also there. Wait, shit, it was, I guess, 2 or 300, but it is higher now somehow. And I messed up. I didn't know how to register as a team, and I registered just myself, and everyone else were sitting idly in my team. So that was a big mistake. Uh, Q, shit. Okay, okay. I guess we can blame this on the website. These questions were good. In this I question, we had to use convex hull. I still haven't looked up how to apply convex hull, but yeah, I'm pretty sure this is going to use convex hull. That is some precision. And then cluster computing. Cluster computing was good. Number maze. Number maze was, yeah, this was kind of almost straightforward. This one was good. This one was good. This one use Descartes algorithm, but not a direct implementation, but indirect one. And this was good. This took uh, quite a bit of, yeah, this took quite a bit of space and time. I think that this can be optimized, but yeah, this was cool. This was cool. And yeah, this stuck on Q. Yeah, I copied your code for F. I was not able to solve share. Didn't use pref, uh, prefix, suffix, GCD. Yes, prefix, suffix, GCD. GCD for prefix and suffix. That was like when I realized, okay, shit, this is what we want. Uh, like yeah, numbers. So the best pair. And yes, whenever we are like pairing up computers, or I don't even remember what the story was. Whenever we are choosing two pairs, the minimum cost is the GCD of the whole thing. So the minimum cost in the whole thing would be choosing the computers at the opposite end, and then whenever we are choosing this for this, the maximum GCD we can hope for is to pair it up with this or to pair it up with this. And we had to make a tree. So yeah, this makes sense. We can just pair these two up and pair every other number either with this or with this. We are not making any cycles, and this is a tree. Cool. Should have a go at South Pacific regionals. Okay. Yes. Yes. Okay. Okay. I will do that. I will do that. I think I can actually become good at competitive programming, because this was actually quite fun. And the fact that these are not arranged in increasing order of difficulty was very fun. Yeah, it was very fun. That was cool. Then knew it was 7 in the morning. Yo, bro got messed up information. Yeah, this was cool. This was cool. And it was just 7 questions. I don't know if that is good or not. And this is still not accepting. Shit, I think I can only give IC. For ICPC. I guess there is regional levels. Ah, yeah. Eligibility must be enrolled in a degree program, be able to compete in world. So can a tech person give ICPC? Yes, shit. Can MSc person give ICPC? Yes. So that is as long as they meet the eligibility requirements. Yeah. Student status. You must be enrolled in a degree program at an institute and be considered at least as a half-time student. Okay, that MSc fills that. Participation limits. You cannot compete if you have already competed in two ICBC World Finals. Okay, I guess yes, I do qualify this. Team competition. Team must have 3 members. Exactly, 3. Registration, you and your team must be fully registered in the official ICBC system. We can do that. Other factors, the specific rules can vary by region, so it is always a good idea to check the rules for the specific regional contest you plan to enter. Said, so that is cool. That is cool. I can do this like with this degree, or even if I go for a higher degree, I can do this. And yes, I won't be doing B.Tech, M.Tech, even if I go for a higher degree or a share. Yeah, MSc would be the thing to go. Yes, we are messing up. -1, -1. And if res smaller than 0, then res equals 0. Four test case, one by one. 1, 0. That is good. 3 by 3. 1, 2, 1, I guess, and then 2, 3, 2, and then 1, 3. Answer is 2. That is also good. And for the third one, we messed up here somehow. This is 1 by 6. We said 1, which is the correct answer. Sure. Okay. Okay. I guess we can submit this and wait for another eternity. See? Shit. Dominator. In Go. Let's go. 5 people, prime number. Shit. And yeah, that would be the end of today's stream. 327, this is stuck. This is not working. Yep, this will take some time. That is cool. And what did we go through? We saw loops. We understand what are loops. That is an amazing feat. We did add-on of code. That is good. And com add-on of code. Here there are branches. For each year there is a branch, and this is very cool. This is just like, yeah, very cool. Normally people have directories by like year this, and then if you go to that year there are days, day one and year this. But here we have branches for each year, which is actually pretty cool. And yeah, we did this 22 commits. 22 commits in this branch. And I think the main branch is 20. So this is 20 commits. Somehow this is further back, 20, 24, 24 commits. Okay, yeah, this is cool. This is cool. And yep, that is cool. That is what we did. I don't have code and go. And yes, that is go. Now slices and maps. Those would be the pretty cool things to learn. Yeah. And that would be the end of today's stream. And thank you for being here.